Okay, well, welcome. Success Jamb class. Currently, we are on this series for chemistry. We're looking at organic chemistry. We're currently looking at organic chemistry for chemistry. Those not joining us today, I'll add you. Message me later. Okay, you already messaged me, and you message me too. Add it to our registered members group. Then I will send you records of all the classes we have done so far. I think we just started like 2 weeks in, so I'll send you the records, so you can have the foundation of how we started, and you can follow up. Even this one also recorded. You can watch it together and follow up. So if there's any day, why we're doing this record is that some of our students are also regular students. If there's any day there's an important test or practical, know that okay, you still have backup. Okay, they are recording the class for you. You understand? Yeah, so you don't miss out completely. So class, we are all welcome. Where did we stop in our organic chemistry class last week, Monday? Those that were around last week, where did we stop? You see? Aldehydes and ketones. Yes, we're looking at. Yes. After looking at primary, secondary, and tertiary alcohols, we then went to aldehydes and ketones. And I think I was showing us how primary alcohols leads to aldehydes, how secondary alcohols lead to ketones, and how tertiary alcohols do not undergo oxidation. That's where we stopped last week. So aldehydes and ketones. Now, generally, we're actually looking at functional groups under organic chemistry. We're looking at the different functional groups under organic chemistry. Because organic chemistry is what we're trying to achieve is the key Jamb topics. The key Jamb topics for Jamb. One of them is organic chemistry. You can't escape the question of organic chemistry in Jamb. It's impossible, literally impossible. So under organic chemistry, we're looking at functional groups. Class. All major families of hydrocarbons or organic compounds contain a major group. Contains a major group that determines the chemical properties of the organic compound. There's a group in each organic compound that determines the major property, chemical property of the organic compound, how the organic compound will react. Are we together? It's the one that determines how the organic compound will react, the reactions that the kind of organic compounds will undergo is determined by the functional group. And functional groups may not just be a group of atoms, they could be bonds. There could be some specific what? Bonds. There could be multiple bonds like double bond, triple bond, can be a functional group. So we looked at the alcohol family. So every family we looked at, if this is a family of hydrocarbon. Alcohols are families of hydrocarbon, and the major functional group there is the hydroxy functional group. We looked at alcohols, and the major functional group in the alcohols is the OH called the hydroxy functional group. Class, as a matter of fact, because of the presence of this OH group, they are called ols. Their naming end is what? Ols. We did that last week. And then we start naming an organic compound depending on the number of carbons they contain. When you contain 1 carbon, your naming will start with met. But an organic compound that contains 2 carbons starts with et. 3 carbons starts with pro. 4 carbons starts with buts. 5 carbons starts with pents. 6 carbons X. So the naming of an organic compound depends on the number of carbon it contains. If you have 7 carbons, so this is 1, 2, 3, 4, 5, 6, 7. If you contain 8 carbons, your name will start with oct. If you have 9 carbons, you're non. And if it's 10 carbons, it's dec. This is how all organic compounds are first named. They are prefixed. The first naming of all organic compounds is dependent on the number of carbon the organic compound contains. Now, so this is what starts the name. What ends the name, class, is the family you belong. For example, if you're an alcohol and you have 1 carbon, you'll be called a methanol, meta. If you're an alcohol and you have 2 carbon, you'll be called an ethanol. If you're an alcohol and you have 3 carbon, you'll be called a propar. 4 carbons, you'll be called a butanol, penta, hexa, heptanol, octanol, nonanol, decanol. You see, the naming, the ending. What ends the name is the family you belong, but what starts your naming is the number of carbons you contain. Now, class, so this alcohol that contains OH group, we didn't stop here. We also went to other families. So if you're not an alcohol, another major family in organic compounds is the alkanals, also known as the aldehydes. Alkanals, also called what? Aldehydes. For the aldehydes, their naming end with now. So now instead of methanol, it will be methanal. Instead of propanol, propanal. So class, number of carbons still stands. If you have one carbon, you are met. This one will never change. But it's now meta, now, eta, now, propa, now, buta, penta, hexa, hepta. So you can see that the beginning still remains the same. If you have one carbon, you are met. But your naming is no longer all because this is a different family. So the family an organic compound belongs to depends on how its naming will end. Are we following? This octanal, nonanal, decanal. Aldehydes. Class, the aldehydes are peculiar because they have the carbonyl functional group. This C double bond O is called carbonyl. This C double bond O is called what? A carbonyl. Carbonyl functional group. If you're just joining us, please know that Mondays we do chemistry, Tuesdays we do physics, Wednesday there's no class, Thursday we do biology, then Friday we have English, use of English on Friday. So it's chemistry on Monday, tomorrow we're coming for physics. Thursday we have no class on Wednesday, you rest on Wednesday, and not that you rest, you revise your past question, revise. I'll tell you, I'll tell them already what they do. Thursday, biology, there's nothing we do, there's a way we do our biology, we also tell you that Fridays, English, use of English. Now class, the major functional group in alkanals is the carbonyl group, C double bond O. So like we are looking at methanal, you're going to draw one carbon. And I told them that when you're drawing the structure of an organic compound, each carbon can only contain 4 bonds. Anytime you're drawing the structure of an organic compound, make sure that the number of bonds on each carbon does not exceed 4. And also it's not less than 4. It must be exactly 4. So for methanal, met means you have one carbon, so you have only one carbon to work with. But you are aware that even if it's only one carbon, for you to be an alkaline, you must contain this functional group. So quickly put the double bond O. Double bond what? O. That's this functional group. This functional group is found in all alkanals. Now, carbon can only have 4 bonds, and these 2 bonds are with oxygen, means can only have extra 2 to make it 4, right? The remaining space, class, after filling up every other thing, the remaining space in an organic compound is filled up with hydrogen. Class, hydrogen is the most popular or the most frequently occurring element in all organic compounds after carbon. After carbon, hydrogen is the most frequently occurring element or atom in organic compounds. Class, this is the structure of methanal. This structure of what? Methanal, 1 carbon. If you want to go to ethanal, ethanal is 2 carbons. We'll just clean 1 hydrogen and increase the carbon length to 2. This ether. Now, ether what? You want to increase to propanal, 3 carbons. Then 1 hydrogen, increase the carbon length, propanal. And you can keep going on and on and on. So we have methanal, ethanal, propanal, butanal. We'll keep going on and on and on. Well, that's for aldehydes, also known as alkanals. We also have another family we call ketones. The ketones also contain the same type of functional group class. Ketones also contain the carbonyl functional group. Ketones are also known as alkanones. Ketones are also called alkanones. Ketones are also known as alkanones. Class, the naming don't end with now, this time I end with nones. So you see that the naming depends on what the family you belong. But class, the funny thing about ketones do not contain these first 3 members. Oh sorry, these first 2 members. Class, the first 2 carbons are absent. So the first member of the ketone family starts from propanol. And do we know why? Because the ketone also contains the carbonyl functional group, just like the aldehyde we did just now. The ketones also contain the carbonyl functional group, just like the aldehyde. But their own carbonyl functional group is not found at the end of the chain. It's found in the middle of the chain. Their carbonyl functional group is found in the middle of the chain, class. So you have C, 3 carbons. The carbonyl group is found at the center. So class, for you to be a ketone, your carbonyl group must be surrounded by 2 other carbons at least. For you to be a ketone, your carbonyl group must be surrounded. This is carbonyl. Carbonyl means carbon with double bond oxygen. For you to be a ketone, your carbonyl group must be surrounded with 2 at least I don't want to say exactly it must be 2. It can be more than 2. But at least 2 extra carbons must be surrounded with your carbonyl. You see why the first number starts from pro, 3 carbons. So for you to be a ketone, you must have at least 3 carbons. You must have at least what? So there's nothing like methanone or ethanone. It doesn't exist. The first member of the ketone family is the propanone. Unlike the aldehyde we just looked at. In the aldehyde, they have this methanol because in the aldehydes, the carbonyl group does not need to have carbon surrounding it. It doesn't need to have carbon surrounding it. If you're just joining, when you watch the other videos, everything I'm saying here will make more sense when you watch the other videos, which I will say to you. Now moving forward, so these guys let me end with propanone, butanone, pentanone, hexanone, as the case may be. I've looked at aldehydes and ketones, and we've looked at alcohols. The next family we actually want to look at now. And class, just to remind you, remember that when you read alcohols, I taught you about primary alcohol, right? Alcohols can vary into primary, secondary, and what? Tertiary. To be sure that those that were around still remember, I want to draw a structure now, an alcohol structure. And without saying anything, I want you to tell me whether that alcohol is primary, secondary, or tertiary. Class. Well, looking at this structure, will you say this alcohol is primary, secondary, or tertiary? Primary, secondary. Let's all complete it. You tertiary. Class, this is a secondary alcohol. This is a secondary alcohol because the carbon bearing the OH group still contains one more hydrogen. This space, any space you are seeing here, class, if they give you a structure, after they have put all they want to put, any other space you are seeing is filled up with what? Hydrogen is one element that does not need to be put there before you know there is hydrogen. Anytime you draw a structure and you are seeing other atoms, any remaining space is filled with what? Hydrogen. Hydrogen. So class, for a secondary alcohol, class, how do we recognize primary, secondary, and tertiary alcohol? You go to the carbon that is carrying the OH group. You go to the what? Because all alcohols must contain OH group, right? All alcohols must contain OH group. We just go to the carbon that is carrying the OH group and find out how many hydrogens are attached to that carbon directly. How many hydrogens are attached to that carbon directly? If there's only one hydrogen attached to the carbon directly, it's a secondary alcohol. It's a what? But if you go to the alcohol and there's no hydrogen attached to it, it's a tertiary alcohol. Look at this one. Class, this is tertiary alcohol. Because look at this carbon bearing the OH group. This is carbon bearing the OH. There is no direct hydrogen attached to it, class. What we have around it is CH3 and OH. There is no direct hydrogen attached to it directly. There is no hydrogen attached to it directly. This is a tertiary alcohol. This is what? It's a common Jamb question. Now, what's the primary alcohol? So you look this secondary. Secondary has only one hydrogen attached to the carbon. Class, there are many hydrogens around it too. But we're not talking about all the hydrogens around it. We're talking about the hydrogen on the we're looking at the carbon bearing the OH group. Miracle, I'm surprised you missed this. Okay. We're looking at the carbon bearing the OH group. Look at this. Anytime the OH group is on the first carbon, just know there is a primary alcohol. Anytime the OH group is on the first, look at these other alcohols. This carbon 1, this carbon 2, the OH group is not on the first carbon. For secondary and tertiary alcohols, the OH group is not on the first, it's usually on the second carbon class. Not usually, it might not be second exactly, it could be third, it could be fourth, but it is never on the first carbon. It's never on the what? First carbon. Class, but for primary alcohol, the OH group is always falling on the first carbon. For primary alcohols, the OH group is always falling on the what? First carbon. For primary alcohols, the OH group is always on the first carbon. First carbon. And another thing you notice about this primary alcohol is that the carbon bearing OH group has two or more hydrogens attached to it directly. Two or more hydrogens attached to it directly. Okay, where were we? So I was talking about primary alcohols. How do you recognize the primary alcohol? The OH group is always on the first. But anytime the OH group is no longer on the first carbon, it is on the second carbon or third carbon or fourth carbon. Just know that it's no longer a primary alcohol. It's no longer what? A primary alcohol. Now, but for secondary alcohol, how do you recognize secondary alcohol? Just trace it, go to the carbon that's bearing the OH. There's always one hydrogen attached to it. Only one. Only what? Only one. So the primary alcohols, recognize them secondary and tertiary. Now, class, one thing I told you also is that the primary alcohols, when they are oxidized, they give rise to the aldehydes. Primary alcohols can undergo oxidation to give what? Aldehydes. To give what? Please take it as a common Jamb question. Secondary alcohols undergo oxidation to give ketones. To give what? Ketones. Tertiary alcohols do not undergo oxidation. Tertiary do not do what? Undergo oxidation. Tertiary alcohol does not undergo oxidation. Tertiary alcohol does not undergo what? Oxidation. Now, class, the next family we want to look at now is the alkanoic acids. The alkanoic acids are also called the carboxylic acids. They are also called the carboxylic acids. Alkanoic acid, also known as the carboxylic acid. Class, these particular ones, carboxylic acid or alkanoic acids, they have two functional groups in them. Class, they contain the carbonyl functional group, also containing the hydroxyl functional group OH. So they contain two functional groups, carbonyl functional group and hydroxyl functional group. So by the time you add carbonyl plus hydroxyl, you have carboxyl. That's how we call them carboxylic acid. That's how we call them what? Carboxylic acid. By the time we have carbonyl plus hydroxyl, we have carboxyl. And we call them the carboxylic acid functional group. Carboxylic acid functional group. Now, this particular family, just like every other family in organic chemistry, they are named based on the number of carbon. Class, just like I told you earlier, if you have one carbon, your naming starts with met. But since you're under this family, you will now be called metanoic acid. If you have two carbons, your naming will start with et. But under this family is ethanoic acid. 3 carbons is pro. But because you belong under this family, it will be propanoic acid. For metanoic acid, you know that everywhere there's an alkanoic acid must contain COOH. Must contain what? But met means one carbon. And the COOH already contains one carbon, means that you can no longer introduce any other carbon. Just fill up the remaining space with hydro. Don't forget that carbon can only have 4 bonds. 1, 2, 3, 4. Please, we are just coming. It's possible that you are a bit lost. Can you come to this side? You're a bit away from the, so you can see well. It's possible that you are lost. You're going to be added to our Jamb class group. We have a group for our Jamb class, and when you're added, I will send you the previous classes before we got here. Are we together? We all have phones now, right? You are connected to the internet, right? Yes, you can see I'm recording this class. All our classes are recorded. So if there's someone that won't join us tomorrow can still get everything he has missed. I'll send you a record of everything you have missed so they can sit down. Wednesdays we are free, so you can sit down. We don't have class on Wednesdays. We have Monday, Tuesday, Thursday, and Friday. So Wednesdays you can sit down and catch up. So everything I'm now saying here will be making sense to you. Oh, that's what you meant. Oh, because you've gotten the foundation. So thank God I recorded it because I know that it's Jamb class. You don't gather Jamb class at once. It's not like you want that everybody's already resumed school. Jamb, something that little person people don't know about us. Some are just getting to know. Some people haven't looking for Jamb class to attend now, but they don't know where to go. So it's like that. So Jamb class takes a bit of time. Most people will not be very, very serious when it's 1 month Jamb. They will not be very, very. That's how students are. You understand? So it's gradual. But if you have started, be serious. If you're not writing Jamb, just leave it. What I'll tell you is this: either you do it well, or don't do it at all. Don't be in the middle. Do it well. If you're doing it well, do it well, and see your score. Give it your best. Give it your what? What I like about Jamb, the Jamb is just a 1-day exam. It's just a 1-day. So it's not April the exam. You write it, you rest. So just see that, okay, after April now, I know I'm done with this, I will rest. You do what? You will rest. It's not something that is maybe like it's a 1-year program. So just set your mind, okay, now I just do this Jamb. After Jamb, now you will rest a bit now, but they will call for post-year. So it's not like it's a WAEC. If it was WAEC, now every day you're having class, every day you're having exam. WAEC almost takes 2 weeks or so. You do practical, you do essay, theory, and OBJ. But Jamb is just 1 day. So just give it your best, give it your absolute best, give it all your best. Give it all your best. So if you say 3 p.m., be here. Follow the time and be around. Follow the time and do what? And be around. So methanoic acid contains only 1 carbon, as you can see. If we are going to ethanoic acid, class, anytime you want to draw the structure of this paper, first draw the functional group. C double bond O and OH. Class, carboxylic acid always contains double bond O and O. But Earth means, class, in organic chemistry terms, when you later watch the video, you see why I call them met, 1 carbon, Earth, 2 carbon, pro, 3 carbons, boot 4. Earth means 2 carbons. So after putting the major functional group, the functional group always contains 1 carbon, and we can only add 1 extra because Earth means 2 carbons. Then you what? Fill up the space for hydrogen, hydrogen. Propanoic acid, start with the functional group again. The functional group is COO. Down, pro means 3 carbons. Class, met means 1 carbon, Earth means 2 carbons, pro means 3. So if there's only 1 carbon, you're adding 2 extra, right? You're adding 2 extra carbons. Propanoic acid, propanoic. If it's boot means 4, pent means 5. Keep going like that and like that. Now, class, I haven't looked at the carboxylic acid. There's a particular type of reaction that the carboxylic acids undergo. It's called esterification reaction. It's called what? Esterification reaction. So write down esterification. Esterification is the reaction between carboxylic acids and alcohols. Esterification is the reaction between carboxylic acids and alcohols. Esterification is the reaction between carboxylic acids and alcohols to form esters and water. Esterification is the reaction between carboxylic acids. Esterification is the reaction between carboxylic acids and alcohols to form esters and water. To form what? Esters and esterification is the reaction between carboxylic acids and alcohols to form esters and water. Class, esters are also known as alkanoids. Esters are also known as alkanoids. Esters are also called alkanoids. Class, when carboxylic acids react with alcohols, they form esters and water. And the reaction is known as what? Esterification reaction. Class, the good thing about this is that we just finished looking at carboxylic acids. And we've also looked at alcohols previously. So the reaction between carboxylic and alcohols, it was give rise to esters and water. Let's show you how this reaction takes place. Let us show you how this reaction does what takes place. Class, normally when carboxylic acid, let's look at the reaction between propanoic acid. Let's look at the reaction between propanoic acid and ethanol. When you hear pro, it means 3 carbons. So you first draw the structure. Noic means that it has COOH, right? When you see noic, you know that it contains COOH because alkanoic acids contain COOH. Pro means 3 carbons, and there's only 1 carbon here, so add 2 extra. And fill up the spaces with what? Hydro. Fill up the spaces with hydrogen. This is propanoic acid. This is propanoic acid. Now, ethanol. Ethanol on the other hand is 2 carbons. Ethanol on the other hand is 2. Et means 2 carbons, but no means you contain the OH group. So the naming of an organic compound can help you know how to draw the structure. When you hear no means you contain OH. When you hear noic, this is COH. I've just told you aldehyde and ketones as well. Aldehydes are also called alkanals. Their naming end with na. Ketones naming end with no. You know what to do. Now, class, this propanoic acid wants to react with this ethanol. This is structure, but let me write it out in normal chemical formula terms. This is C3. This is 3 carbons, right? This is C3. How many hydrogens? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There should be another. Wait, 1, 2, 3, 4. Something looks off. Okay, let's just say this is C2. H5, this C2H5 COO, C2H5 COO plus C2H5OH plus C2H5O. This is what we call condensed structure, condensed formula. You don't want to be showing all these bonds. You just want to write down the structure alone without the bonds. So it's C2, H, how many hydrogens? 5 and H5, COO, and C2, H1, 2, 3, 4, C2H5O. In this way, you are writing out the organic compound in terms of the alkyl group it contains, plus the functional group present, plus the functional group. FG means functional group. The major functional group in this propanoic acid is COO, and the major functional group in this ethanol is O. Class, this is the alkyl group, ethyl. The alkyl group is also ethyl. So the alkyl group and the major functional group it contains. This is another way of writing organic compounds. You're writing the alkyl group and the major functional group it contains. Alkyl group and the major functional group it. Class, when these two react, please note that hydrogen is lost from the alkanoic acid and OH is lost from the alcohol. So that the reaction will now give, class, hydrogen is lost from the alkanoic acid, hydrogen is lost from the what? And OH is lost from the what? Alcohol. When hydrogen that's lost here plus OH that's lost here will form water. Will form what? H2O, water. Don't forget that during esterification, ester plus water is formed. These are the water is formed. These are the water is what? Formed. Okay, so we've seen how hydrogen is lost here, OH is lost here. Class, what is left between these two will now join together. Class, this C2H5, I'm coming from here, C2H COO, right, is left. H has gone, right? C2H5CO, and what's left here, C2H. This is the ester that is formed, and I must teach you how to name esters. This is the ester that is what? What did I say esters are also called? Alkyl. How do you name esters? Now you name esters from the alkyl group in front. This ethyl. This what? So you start naming from this ethyl. Because esters naming must end with no H because they are alkanoid. They are alkyl. Why is this ethyl? 2 carbons. Ethyl. This 2 carbons plus 1, 3. Propanoids. Ethyl propanoids. Ethyl what? Propa. Why is this pro? Because there are 3. 2 plus 1 is what? 3. This ethyl group, so we call this ethyl propanoids. Let's show you how to draw the structure. Let's show you how to rush. Please, if you don't miss class, sometimes you see that probably that we're not here in the last week when we started this organic chemistry. If imagine missing more, now you'll be missing, you'll be more lost. Please try and be consistent. Try to be consistent. For this period of the Jamb, let this Jamb be your priority. I'm telling you because it's the one that is time. It's based on time, and if you get it, it supersedes every other thing you're doing on now. Since that's the course you actually want. So let this be your priority. I know why I'm saying this because by April, when is the Jamb? Is April what? April 28. Before you know it, you've written your Jamb and you have gone your way and continue every other program. But please let this be your priority. Let this be give it your priority. Just 2 months, less than 2 months program. Do it well. Do it well. If we give you assignments to go and do so and so here, go and do it. I'll be giving you some years to go and do. I'm also making inquiries to see how we can get informed and know what's going on because we want you to score well in this Jamb. So class, you can see what happens here. I was about showing you the structure. Class. How do you draw this in the structure? So this is C2H5, C2H5, H what? C2H5, COO, right? This C double bond or another O here. Then C2H. Like this is the structure. This is the structure. C2H5, COO, C2H5, C2H5. You giving her, right? You didn't say her? Eh? Yes, now that's a microbiology now. Yes, give her. It's the one. Don't forget when naming them, you start with ethyl propanoate. Ethyl propanoate. Yes. Yeah. In this C. You know why they are arranged here? Carbon can only have 4 bonds. Look at this carbon already. 1, 2, 3. So you're not allowed to put another bond here. Good question. Please know when you're drawing your structure for organic compound. Carbon, or check all my carbons. They only have 4 bonds around them. Start with this. 1, 2, 3. Start with this 1, 2, 3. This 1, 2, 3. This 1, 2, 3. 1, 2, 3. Carbon can only have what? 4 bonds. It must not be more than 4. It must not be less than 4. Well, let me see if you've gotten it. Everybody, give me show the reaction between. I'll give it 1 carbonic acid and 1 alcohol to react them, and what is the ester and water that is formed. Let us look at the reaction between butanoic acid, and methanol. Another one, methanoic acid and propanol. Please give me what will happen when this reacts with this. What is the ester form? We know that water will be formed, that is sure. What's the ester form? Okay, let's look at it together. If possible, you've not still gotten it, it's understandable. We just started. It's understandable. Class, butanoic acid, of course, as I told you, when you hear but, how many carbons come to mind? 4. But class, start with the noic. Noic means I definitely have a carbon, this and this, right? All organic compounds that end with noic contains this functional group. Now, but means 4 carbon, but there's already 1 carbon there, so you're adding 3 extra to make it 4, right? Butanoic. H. Now reacting with methanol. Who is methanol? Methanol means met, of course, means that you have only 1 carbon. Met means 1. And O means that you definitely have an OH group. Fill up the last space with hydrogen. How do I know how many hydrogens to put? Because carbon can only have 4 bonds. So if 1 bond is taking OH, The remaining 3 spaces will fill out with hydrogen. What did I say happens during esterification? Because anytime carboxylic acid comes in contact with alcohol, esterification will occur. Anytime carboxylic acids come in contact with alcohol, esterification will do what? Occur. What happens during esterification is that hydrogen is lost from the alkanoic acid and OH is lost from this. H plus OH will give water, will give what? That's how the H2O is formed. And the rest components of these two will combine together. So this one, let's write in terms of alkyl group and the functional group. 1, 2, 3. C3H7. So this is C3, CH7, COOH, COO plus CH3OH, CHO. But remember that this H and OH have been lost. So what is remaining here will now join what's remaining here to give us what? C3, H7, COO, CH3. Are we together? C3, H7, COO, CH. That's what you're going to have. And when naming this now, you start naming from this alkyl group in front. This one carbon is methyl. In case you're just coming and you're having confusion recognizing this person here, they are under the alkyl group. I've taught alkyl groups. When I send the video, you will see, you'll be able to follow up. Yes, alkyl groups, you have methyl, propyl. Please try and be consistent so we don't keep going back and forth. Try and be consistent. So this is methyl, we call this guy methyl. How many carbons are here? 3 plus 1, 4. 4 means good. 4 means what? After naming this methyl good, you don't say methyl butanoate, but see what? Esters naming must end with noate. Esters naming end with what? Noate. Methyl butanoate. Methyl butanoate. Now, let's look at the second person. Methanoic acid means that definitely you have COH, but met means you have one carbon and there's only one carbon here. You cannot add any other carbon here again. Just fill up the main space with hydro. Hydrogen is what you bring in when there's nothing else you can bring in. This is the structure of methanoic acid. Reacting with propanol. Propanol is 3 carbons. Pro means 3 carbons. This OH. Methanoic acid reacting with propanol. Don't forget I said this guy is the one that loses hydrogen and this guy loses OH. What will be left if H and OH has gone will be HCOO. And what's left? C3H7, C3H plus H2. This is the ester that is formed. This is the ester that is. And what ester is this? Propyl methanoate. Propyl methanoate. Propyl methanoate. Propyl what? Methanoate. Why is it propyl? 3 carbons pro. Met because only 1 carbon has been here. Propyl methanoate. Now, you not see? C3 H1 2 3 4 5 6. No, I added it now. HCOO. No, it's not plus. HCOO will now be added to every other person here. This OH and H has gone now. Remember how we used to do it? There's this, and what is the many here that will join? Class. In the exam, it could be asked. The opposite of this reaction is called hydrolysis, class. The opposite of esterification reaction is hydrolysis. So, class, the reaction between alkanoic acid and alcohol gives ester and water. It's called esterification. But the reaction between ester and water to give back alkanoic acid and alcohol is called hydrolysis. It's called what? So the reverse reaction is hydrolysis. The reverse reaction is what? Why the forward reaction is esterification, the reverse reaction is hydrolysis. Why the forward reaction is esterification, the reverse reaction is hydrolysis. Why the forward reaction is esterification, the reverse reaction is hydrolysis. Now the next family we want to look at is amines. Let's look at amines. Amines. A-M-I-N-E-S. Amines. Class, the amine functional group are derivatives of ammonia. The amine functional group are derivatives of what? Ammonia, in bracket NH3. The amine functional groups are derivative of what? Ammonia, in bracket what? NH3. The amine functional group are what? Derivative of what? Ammonia, in bracket what? NH3. And they are formed when one or more hydrogen atom is lost from the ammonia what group, and they are formed when one or more hydrogen atom, let's not say it's lost, when one or more hydrogen atom has been replaced by an alkyl group, and they are formed when one or more hydrogen atom has been replaced by an alkyl group. Class, we can have primary amine, so they can be classified into three: primary, secondary, and tertiary. In your Jamb, you could be asked, select out among the options the secondary amine. What should you see in the exam that will help you to know that this is a secondary amine? What should you see that will help you know this is a primary? So amines can be classified, I hope you're writing, amines can be classified into primary, secondary, and tertiary. Now let's start with primary amines. Let me quickly explain before you write down. Look at amine. Look up, let me explain first. Amines are derivatives of ammonia. Ammonia is NH3, meaning N bonded to 3 hydrogens. 3 what? N bonded to 3 hydrogens. N bonded to 3 hydrogens. Class, when nitrogen is bonded to 3 hydrogens, ammonia, we have ammonia. Now, what of amine? There's a difference between ammonia and amine. This is ammonia, it's not yet an organic compound. It becomes an organic compound when carbon comes into it, because you cannot be an organic compound without containing carbon. All organic compounds contain carbon. So for you to be an organic compound, you must first contain carbon, you must first contain. Without carbon, you cannot be called an organic compound. So ammonia like this is not an organic compound until one of its hydrogen is replaced with an alkyl group like CA3. CA3 is an alkyl group. This alkyl group keeps occurring in all things we are teaching. Anybody that meets the alkyl class is lost, obviously. Class, alkyl groups are a group of organic compounds that lack just one more hydrogen less. Their naming end with YL. Methyl is CA3. Please get used to them. Ethyl is C2H. Propyl is C3H7. They are not families that stand on their own. They are always found attached as branches. They are always occurring as what? Branches. They are never standing on their own. Butyl C4H9. Notice that they still maintain the met 1 carbon, et 2 carbons, pro 3 carbons, 4 but 4 carbons. So when methyl, this methyl CA3 has replaced one hydrogen in ammonia, a primary amine is. So the primary amine is what? So What of secondary amine? From secondary amine is from when two hydrogens have been replaced on the ammonia. Secondary amine is. And tertiary amine is from when all the hydrogens have been what? Replaced with an alkyl group. A tertiary amine is formed. So what makes you a primary amine? When only one hydrogen is replaced, right? Primary. What makes you secondary? When two hydrogens have been. And what makes you tertiary? When all the three hydrogens have been what? You now become a tertiary amine. So come again, primary amine is only when one hydrogen has been. Secondary, when two hydrogens have been. Tertiary, when the three have been. We'll not teach you how to name it. We'll not teach you how to do what? Name. But first of all, let's have the notes in your book. Primary amines are formed. Primary amines are formed when one hydrogen is replaced. When one hydrogen of the ammonia group is replaced by an alkyl group. Primary amine is formed when one hydrogen of ammonia group is replaced. Primary amines are formed when one hydrogen of the ammonia group is replaced by an alkyl group. Primary amines are formed when one hydrogen of the ammonia group is what? Is replaced by the alkyl group. When one hydrogen of the ammonia group is replaced by the alkyl group. Example, class. Let's return back to when only one hydrogen has been replaced. So we still have hydrogen here. This now becomes CH3, NH2. NH what? Class, there are two ways of naming primary amines. Class, you can name this as, what is CH3? This is not methyl. So you can say methyl amine. Methyl what? Amine. Methyl amine. Class, I want to remind you, look up, that the difference between this alkyl group and alkane, there's a family called alkane. Is just one extra hydrogen. Class, this is CH3, right? If I add one extra hydrogen here, it becomes CH, and this becomes methane. So from methyl to methane. This is C2H5, right? If I add one extra hydrogen, it becomes C2H6. It becomes E. So what I want to tell you is that if you don't want to name this amine as methyl amine, this methyl is almost methane, it's just one hydrogen less, so I can call it what? Aminomethane. Because this Na2 functional group is the amino group. Is the what? Amino group. This Na2 group you are seeing here is the amino group. So this can be called aminomethane. Amino what? Methane. Aminomethane. Or methyl amine. Or methyl. If this was not C3, what if this was C2H5? What would it have been? Ethyl. Because C2H5 is ethyl, right? Amine. Or what? Aminoethane. Amino what? Ethane. Aminoethane. Class. If we have longer chains of carbon, the amino group could be exhibit what we call positional change. Look at this. And let's assume all these spaces are filled with hydro. This 1, 2, 3, 4, 5. This is not pent. In organic chemistry terms, when you have 5 carbons, you are pent. So this is pentane. And the amino group is on the first carbon, so this one amino what? Because this Na2 is called an amino group. This Na2 is called what? This becomes one amino pentane. But class, what if we shift this amino group to the second carbon? Instead of one, what we now call it? 2 amino pentane. 2 what? What if there are 2 amino groups, Na2, Na2, according here? One on carbon 2 and one on carbon 3. There's one amino group of carbon 2, another on carbon 3. It will be 2, 3, diamino pentane. Di means that they are occurring twice. 2, 3, diamino pentane. 2, 3, diamino pentane. 2, 3, diamino pentane. That means the one amino group is on the second carbon and one is on the third. So don't get so used to saying methyl or, because once they are pertaining to, you have to name it as an amino methane or amino alkane, as the case may be. Now class, that's for primary amine. Now moving to secondary amines. Class, right now secondary amines are amines formed when two hydrogens of the amino group have been replaced by an alkyl group. Secondary amines are amines formed. Secondary amines are amines formed when two hydrogens of the ammonia group have been completely replaced by what? The alkyl groups. When two hydrogens of the ammonia group have been completely what? Replaced by the what? By the alkyl group. So class, for secondary amines, you find things like this. That apart from having this hydrogen has been replaced, let's say CA3, this second hydrogen has also been replaced with maybe CA3 as well, or another alkyl group, or another alkyl group. And the naming now will be, this is methyl, this is methyl. So we say dimethylamine, 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 dimethylamine. Class, secondary and tertiary amines cannot be named as amino alkanes. Only primary amines, which I showed you, can be named as amino alkanes. Secondary and tertiary amines cannot be named as amino alkanes. Are we together? So this is dimethylamine. What if there were two different alkyl groups? Like this was C2H5 and this C3. C2H5 is called what? Ethyl, right? So this is now ethyl. Class, start alphabetically. E should come before M. In organic chemistry, organic compound naming, attention must be paid to detail. Every detail matters. Class, there's a big difference between someone that mentions ethyl first before methyl. Because alphabetically A comes before M. So you're going to say ethyl, methyl, amine. Ethyl, methyl, amine. But when they were the same, it's dimethylamine. But when they are different, like if this CA3, this is methyl, and this ethyl. So this ethyl, methyl, amine. What if two of them were C2H5, C2H5? It will be di-ethyl. Di what? Diethylamine. Diethyl. That means these two are the same. Diethylamine. Diethyl what? Amine. Because this C2H5 is C2H5. C2H5 is called what? Ethyl. The C2H5 group is called ethyl. So we're going to say diethylamine. Are we together, class? Tertiary amines. Now let's write down. Tertiary amines are formed when all three hydrogens of the ammonia group have been replaced. Tertiary amines are formed. Tertiary amines are formed when all three hydrogens of the ammonia group have been replaced by alkyl groups. Tertiary amines are formed when all three hydrogens of the ammonia group have been what? Replaced by the alkyl group. Tertiary amines are formed. Are you lost somewhere? Okay. Tertiary amines are formed when all three hydrogens of the what? Ammonia group have been what? Replaced by the alkyl group. That means for tertiary amines, there is no hydrogen directly attached to the nitrogen. There is no hydrogen directly attached to the nitro. So even this guy has been replaced with something, class. Class, for tertiary amine, let me give you a typical example of tertiary amine. In tertiary amine, there are 3 alkyl groups surrounding the nitrogen, right? Class, the person with the longest carbon is the parent name, is the what? Why this other 2 now becomes a branch? If there are 3 carbons here and they CA3 here and they C2H5 here, see how we're going to name this? We are going to say N. This ethyl, right? C2H5 is ethyl. This me. Class, E should come before M. So N-ethyl, N-methyl, 3 carbons, propylamine. Pro. The parent name is propyl. Why is propylamine the parent name? Pro means 3 carbons. The 3 carbons that the longest chain of carbon is the parent name. The longest chain of carbon is the what? Parent name. So this guy has 3 carbons. This one has only 1 carbon. This one has 2 carbons. So this will be the ending name, propylamine. So these other 2 now become branches. N-ethyl means that there is an ethyl group attached to the N group, nitrogen group. N-methyl means that there is a methyl group attached to the nitrogen group. So we are going to say N-ethyl, N-methyl, propyl, propyl is 3, C3H7, propyl, amine. But in the case that all the 3 alkyl groups have the same number of carbon, like CA3, CH3, we will just say trimethylamine. Trimethylamine. Nobody has the longest. Trimethylamine. Trimethyl what? Amine. When you're done writing, let's go to the amide. There's nothing amine and amide. A-M-I-D-A. What we'll just look at now is amine. A-M-I-N-E. Let's look at amide. A-M-I-D-E. A-M-I-D-E. You're still writing? The amide family, you're still writing, let me pause a bit, write fast. Amides. Right, amides are organic compounds containing 2 major functional groups. Amides are organic compounds containing 2 major functional groups. Amides are organic compounds containing 2 major functional groups. One is the carbonyl functional group, carbonyl, and the what? Amino functional group. They contain the carbonyl functional group and the amino functional. So you will see these 2 major functional groups. So this is an amide. You know this is a what? An amide. If it's an amine just contains NH2. NH2. It doesn't contain C double bond O. But amide contains NH2 and C double bond O. Class. So we're going to have something like this. Then you have an alkyl group here. Class, we use arrow to represent an alkyl group. R is the symbol or the letter we use to represent what? Alkyl groups. Alkyl groups is what I was showing here. Methyl, ethyl, propyl. You get? So class, just like we have amine, primary, secondary, and tertiary, we also have primary amide. Primary what? Secondary amide. How many things have we done so far that have primary, secondary, and tertiary? Alcohol, right? Alcohol has primary, secondary, and tertiary. We have primary alcohol, we have secondary alcohol, we have tertiary alcohol. Please don't forget, if you just coming in, all the videos of previous class that is, so I can catch up and understand what we're doing. If you watch those videos very well, you say, oh, okay, so this is what we were saying. To make what we're doing now make more sense. So don't worry yourself. We will still have the recording. Okay. Class. If These two hydrogens in this amino group are still intact. Just know they are dealing with a primary amide. They're dealing with the primary. If these two hydrogens in this amino group are still, you are dealing with a primary amide. For example, this is a primary amide. How do you know this primary amide? This is 1, 2, right? 2 carbons is 8, right? So this is ethanamide. 8, 2 carbons, 8, 2. If it was to be 1 carbon, it will be methanamide. If it's 1 carbon, it will have a methanamide. If it was 1 carbon, it will have a methanamide. But 2 carbons, ethana, 3 carbons, propana. So primary amides are recognized in the sense that the amino group still has 2 hydrogens. Class, what is now a secondary amide? A secondary amide is formed when one of the hydrogen of the amino group has been replaced. Write down the secondary amide. Secondary amide is formed. The secondary amide is formed when one hydrogen of the amino group has been replaced by an alkyl group. When one hydrogen of the amino group, the secondary amide is formed when one hydrogen of the amino group has been what? Replaced by what? By an alkyl group. When one hydrogen of the amino group, has been replaced by what? By an alkyl group. Secondary amide is formed when one hydrogen of the amino group has been what? Replaced by an alkyl group. Let's see how that will take effect. Class, notice that we have 2 hydrogens here now. Imagine one hydrogen has gone and only one is remaining, and that hydrogen is replaced with CH3. So what we now have is now only one hydrogen. Class, to name this, we are going to say that this CH3 is a methyl group, right? So we are going to say N-methyl. N what? And what was the original name? 2-ethana. N-methyl, ethana. What I'm doing so far now is nomenclature. I will still come to reactions. The reactions part, at least, we'll focus more on alkane, alkynes, benzenes, and a little on alcohol, test for all those things, look at them. Anyone that concerns your Jamb, as regards your Jamb chemistry. N-methyl ethanamide. N-methyl ethanamide. N-methyl ethanamide. Let's do tertiary amide. Tertiary amide, right? No, for tertiary amides, all 2 hydrogens of the amino group have been replaced. For tertiary amides, all 2 hydrogens of the amino group have been replaced. For tertiary amides, all 2 hydrogens of the amino group have been replaced by alkyl groups. For tertiary amides, all 2 hydrogens of the amino group have been what? Replaced. All 2 hydrogens of the amino group have been replaced by alkyl groups. Meaning that even this other hydrogen has been replaced by alkyl groups. Let us say the same CH3 that came here. If it is the same CH3, it will now be NN dimethyl, N for this, another N for NN dimethyl ethanamide. NN dimethyl ethanol. N for this, another N for, that's the NN dimethyl ethanol. This is a tertiary amide. This is a tertiary what? Amide. So in tertiary amide, you will not find any hydrogen directly attached here for a tertiary what? Amide. So just put key points, key exam point on the organic compounds. Note, primary amines have the ability to turn red, not separ blue. Primary amines have the ability to turn what? Red, not separ blue because they are basic. Primary amines, what are primary amines? RNH2. Primary amines are amines that only one hydrogen has been replaced, right? Have the ability to turn red, not separ what? Blue. Primary amines have the ability to turn what? Red, not separ what? Blue. Primary amines have the ability to turn red, not separ blue because they are what? Base. Remember that bases have the ability to turn what? Red, litmus paper, blue. Which of the following family of organic compounds is used for sterilization? It's used for what? Sterilization and preservation of specimens and food. Class. Which of the following family do you think is used to sterilize? That is to kill bacteria. Do you think it will be esters? Do you think it will be alkanoic acids, alcohols, or alkynes? Alcohols, right? Good. You're thinking. Alcohols are the ones that use what? Sterilize. Sterilization and preservation of food specimens, alcohol. Which of the following reagents is used to test for alcohols? Which of the following reagents is used to test for alcohols? A. Lucas reagents. B. Benedict's reagents. C. Acetylites. D. None. Class, the answer is Lucas reagent. We don't have time to play, but the time is next month. So Lucas, just go and pass, just go and pass. Class, are you aware that among all organic compounds, the organic compound with this pleasant smell is esters? Is what? Esters. I should have said that. Esters have a pleasant smell, actually, class. The organic compound with this pleasant smell is what? Esters. They are also called alkanoids. Esters, the organic compound with a pleasant smell. They have a pleasant smell. Esters, alkanoids. Class. You could be asked in the exam, which was one of the reagents that helps us to distinguish between aldehydes and ketones? Class, we have aldehydes and we have what? Ketones. Remember, aldehydes and ketones have the same functional group. The carbonic functional. Aldehydes and ketones have the same functional with carbonic functional. So it can be very confusing. What reagent is used to help us to distinguish between two of them is what? Tollene's reagent, right? And Tollene's. Please note this in their key Jamb topics. So there will be a time, I'll be entering like next 2 weeks from now, we'll be going into serious example because Jamb, like things I'll be bringing, I'll be teaching, just note them. Note them. Jamb is just 40 questions. Jamb is just 40 chemistry. It's just 40. Physics is just need to be directed, not just a normal class. As I said, this is not a normal class. So I know what I'm doing. That's some things I will bring in key points. Just pick them, pick them. Anybody that answer that 40 correctly is OBG. That's clear that 40 in chemistry, 40 in physics, 40 in biology, and then 40 in English. Those doing engineering will be math instead of biology, Abby. Those going for engineering, I think we're having mathematics instead of what? Biology. Two of you are going for math, right? You come for math on Wednesday. Yes, because two of you are the first students that we have doing math. All our Jamb students so far have not been writing maths. So two of you only. Class. Cyclic hydrocarbons. Example, we have the cycloalkanes. We have the benzenes. We have the what? We have the cycloalkanes, we have the benzenes. We have the cyclic hydrocarbons. Hydrocarbons who are represented with what? A polygon, in which the number of sides of the polygon represents the number of carbon. Cyclic hydrocarbons represented with a what? A polygon, in which the number of sides of the polygon represents the number of what? Carbon present. The number of sides of the polygon represents the number of carbon present. The number of sides of the polygon represents the number of carbon present. The number of sides of the polygon represents the number of carbon present. The number of sides of the what? Polygon represents the number of carbon present. The number of sides of the polygon represents the number of carbon present. So class, their naming starts with cyclo. Then you count the number of sides. 1, 2, 3. When you have 3 sides, means you have 3 carbons. Propane. So this is cyclopropane. This is cyclo what? Propane. Count the number of sides. Count the number of sides. 1, 2, 3, and then pro. So this is cyclo, then propane. Cyclo, then what? Propane. If you have 4 sides, this will be cyclobutane. Cyclo what? Butane. 1, 2, 3, 4. 4 sides. Butane. A cyclic compound that has 5 sides is cyclopentane. The number of sides represents number of carbon. Number of sides represents number of carbon. And you have 6. Of course, in organic chemistry you have 6 carbons. Don't be that later comment. When you watch the video, you see how we talk number of carbons and we name them. This cyclohexane, when you have 6 sides in organic compounds, you are X. You are what? X. Hexane. Cyclohexane. So this for cycloalkanes. Cyclo what? Alkanes. For class. Coming to benzenes. Benzenes are also known as aromatic compounds. Benzenes are also known as what? Aromatic organic compounds. Class. So the benzenes, they have exactly 6 sides. The benzenes are also cyclic hydrocarbons, but with 6 sides. If you have less than 6 sides or more than 6 sides, you are not a benzene. You are not the benzene. You must have 6 sides. And their naming don't start with cyclo class. They are simply called benzenes. They are simply called what? One peculiar feature of benzene is that they have 6 sides. So 1, 2, 3, 4, 5. And there's alternating double and single bond in the structure. So after every double bond is a single bond, after every double bond is a single bond. So benzene contains 3 double bonds and 3 single. So there are 3 double bonds and 3 single bonds in the benzene ring. There are 3 double bonds and 3 single bonds in the benzene ring. There are 3 double bonds and 3 single bonds in the benzene ring. Class. Anybody attached to the benzene is named as a branch, then you mention benzene. If you put CA3 here, what we call this? This is methyl. You can say 1-methyl benzene. Because you put CA3 there, right? If it was chlorine, it would be 1-chlorobenzene. 1-chloro what? If it was bromine, Br, 1-bromobenzene. If it was NH2, 1-amino, NH2 is an amino group, remember? 1-amino ben. If it was NO2, NO, 1-nitro, benzene. If it was CN, C what? 1 cyano benzene. 1 cyano benzene. Write those things down, write those things down. Class, note that benzenes can undergo catalytic hydrogenation to produce cyclohexane. Benzenes can undergo catalytic what? Hydrogenation. Class, addition of specific number of hydrogens to this benzene can break all the double bond and become cyclo what? Hexane. Class, this is benzene now, but there's another structure that also has 6 sides, but it doesn't have a double bond inside like benzene. This is benzene class. This is ben. But this guy is cyclo, and inside 6 side hexane. So I told you that catalytic hydrogenation, addition of required number of hydrogen to this, and we require catalyst like palladium catalyst Pg or platinum catalyst Pt, palladium or platinum catalyst could cause what? Hydrogenation of catalytic hydrogenation of benzene gives what? What? Cyclohexane. In the exam, you could be asked, the type of reaction that's peculiar to benzene is substitution reaction. Please take note. We are not in terms of reaction here, but just take the substitution. The type of reaction peculiar to benzene is substitution reaction. The type of reaction peculiar to benzene is substitution reaction. Class, there's a family of benzene that is popularly used as a disinfectant. There's a family of benzene that is popularly used as a disinfectant. Who can tell me that without me telling you first? Let me see. I'm telling you what you know. Tell me. Which family of benzene is popularly used as a disinfectant? So we have all failed it in Jamb, right? So write down. The family of benzene that is popularly used as a disinfectant is phenol. Is what? Who is phenol class? It's benzene with OH class. Benzene with what? It's called phenol. Actually, it's called 1-hydroxyl benzene. 1-hydroxyl. Just like when methyl was there for 1-methyl benzene, right? When chlorine was there, 1-chloro, 1-bromo, 1-hydroxyl class. When 1 OH is attached to a benzene, you can generally call it a phenol. The general name for hydroxyl benzene is what? Phenol. The general name for hydroxyl benzene is what? Phenol is the family of benzene that is popularly used as a disinfectant. Class, another thing that concerns benzene is the vulcanizer solution. There's what we call vulcanizer solution. The vulcanizer solution is prepared, write down, by dissolving rubber in benzene. The vulcanizer solution is prepared by dissolving rubber in what? Benzene. The vulcanizer solution is prepared by dissolving rubber in what? Benzene. The vulcanizer solution is prepared by dissolving what? Rubber. R-U-B-B-R, rubber now. In benzene, by dissolving rubber in benzene. Vulcanizer solution is prepared by dissolving rubber in what? Benzene. Class, this one you know. So the ability of carbon to form long chains with one another is called catenation. Please take note. So are you noticing that in organic compounds are seeing carbon, 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 carbon? this thing that organic structures are doing with each other, carbon, 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 is called catenation. The ability of carbon to form long chains with each other is referred to as catenation. Which of the following organic compound is used as fuel in the miner's lamp? Which of the following organic compound is used as fuel in the miner's lamp? These things, you might not see them in any textbook. If you don't know, you don't know it. Ethane, ethyne, benzene. Which of them is used as fuel in the miner's lamp? Answer? Answer is ethyne. Answer is what? Ethyne is used as fuel in the miner's lamp. Please take notes. Ethyne is used as fuel in the what? Miner's lamp. Ethane. Which of these following uses aids ripening of fruits? Ethane. If they say aids ripening of fruits, ethane is a major plant hormone, also known as ethylene. Ethane is a major plant hormone, also known as ethylene, that aids ripening of fruits. Good. Which of the following compounds is a tertiary alkanol? Thank God I taught it here. Which of the following compounds is a tertiary what? Alkanol. Let's look at the options they gave. Which of the following compounds is a tertiary alkanol? A, we have CH3, CH3OH. B, CH3, CH3OH, CH2, CH3. C, CH3, CH3, CH2OH. D, CH3, CH3, CH2OH. Which of the following is a tertiary alkanol? B is tertiary, right? You are correct. B is tertiary because there is no hydrogen directly attached to its class. We want to start our past question 2 years. Every time we come, I'll give you 2 years of passing that you will do. And the next time we meet, we are first going to solve through those 2 years. This each well, sometimes we might be staying till 3 to 5:30. Let's just do it well. Let's just do it. It's Jamb. It's what? Just do it well. After this, how many months? It's just less than 2 months, Abi. Clear the Jamb, everybody rest. It's a time, so it's one thing, anything that I didn't was throughout the whole year. I say, I'm working myself the whole year. But it's not a whole year something. Just arrange your mind, okay, let me just give this 2 months this Jamb, let me just give my gap throw and see what comes. And then I've tried mine. What will be painful is that Jamb held and you not even try your best. Like just do it anyhow, just do it well. So now I did mine. Clear your conscience, I did mine. I know it's not easy, it's stressful. I know it's not easy, it's what? It's stressful, it's not easy. I understand. But let's just do it what? Well. So please, the 2 years for chemistry, I want to give you, starting from this week, get Jamb pass question. You can't be working with us and you don't have Jamb pass question. Please, we want to start entering serious work now. This March. Say we're in March now. There's no time to waste. If you see the level, when I teach when I'm teaching the level audience, I have as if I'm more writing the exam. That's how I do, because I feel the need of the students to want to do well. I put myself in a student's shoe. They want to come on. We came to this Jamb class because you want to score high in your Jamb. So I want to meet that request. So everything I need to do to achieve it, I will do it. Get Jamb pass question. This one is my own. I bought. This is my copy. I bought Jamb pass question. So everything I tell myself, I also do it. I have to lead by example. But I'm not writing Jamb, but I bought it so that I can need to teach. I can also have direction. When we're marking, or we want to be working on Jamb, we want to work on Jamb pass. After doing one particular year, we'll be branching into different things. I've done with English on Friday. Check the dictionary, what's the meaning of this, check the vocabulary of this. That's how we do chemistry, to do biology, do English. See, I've given you 2 years in biology already from last week, right? I told you I gave you 2 topics to read. Please, if you're just joining us and you're doing biology in Jamb, I give them 2 topics. Please still catch up. What are the 2 topics? So we can now read it. Yes. Let's just do it together. Let's just and cell biology. Read circulatory system and cell biology. Look for a biology textbook. Study. And I told them how to read the form notes, read, go through the Jamb pass question and study. Nobody gets any high score with just sitting down. We will not get it all. I'm telling you now, don't say I promised you magic if you're not ready to work. I was asking, are you ready? I was asking him, most of you that went to before you joined, I was keep asking you, why you ask? I said, I don't just select any kind of student. If you don't want to pass, just go. I won't just say because you want to pay, I'll just collect them. No, if you don't want to pass, if you're not ready to put in your effort, just go. Go. Because this kind of score we want to get. This kind of score we're looking for. So just go. I'll say just go. You're not serious, just go. Leave it. I don't just want, I want also to do something extraordinary. It's possible, very possible. What's 300 in Jamb? What's 300? Very possible. Very what? But it starts from you believing and putting in the effort. Putting in the what? Yes, checkpoint. You just, how much there by this? Is it 4,045? It's not expensive. 4,045 in Choba campus. The Choba junction, I bought it. This is my copy. Eh? Yes. Look, I'll give you 2 years of chemistry band. 2 years. It's all the courses are inside. So it's just chemistry, physics, even there's math inside, there's biology, there's chemistry, there's English. And it's latest years inside, combined. So it's not like this biology, then there's one for chemistry. Everything is in. There's chemistry inside it, there's physics inside it, there's, you get? With the solution. So, are you here, my guys? What's your name? I didn't get your name. 18. Precious. You don't have to bring it in this thing. Hey. No joy, what's happening now? You are the senior. So you say the land you village name first, then you know come in. So Precious and 18. Don't be missing our classes. We message me after a general Jamb. It's a serious class, you can see. I like consistent students. If not, I'll tell your brother. Like, I know your brother, but say that you should join my Jamb class. But I need serious. He knows me, so I don't joke. I don't joke with my classes. You need to be what? You need to be serious. So class, the year we're doing assignment, take down the assignments for chemistry. So please, everybody that just joined today, the next time I want to see you with your Jamb pass question. Go and buy it in Choba campus. It's a requirement. You're not allowed in my class. You don't have Jamb pass. I'm not selling it, but go and buy. You need it. You need. But let's see how the pass question inside. No problem. Let that one you have. So you have to pass on to the latest year. Okay. That means not going to listen. Yeah, no, I'll bring it. I just need Jamb pass. Oh yeah, let's start. Let's give you 2 years. 2 years assignment. Take. You go and do so that when you have to come now, you've already done it. I will not be solving correction, be solving. You are solving is allowing me to remember something. I will teach you. I'll teach you. Because this I'm not remembering. You have to use person to remind me. I'll teach you. This take note of this, take note of this. Will be branching, teaching different things. Because if you just sit there in organic chemistry is very big. You can spend the whole month and not finish organic. But if you have done 2, if I give you assignment 2 years of Jamb pass, by the time you are coming and that year, there's no way that 2 years have not sent us to different topics. Number 1, I sent us to matter. I will taught number 3. When I'm doing the correction now. So by doing 2 years, I've taught several topics for you. That's why I say I need time. I will need. So next week Monday, eat well. Please eat. Go and plan yourself. Eat well. Let us pass this Jamb. If you're not doing it, let's not just do it. Or if we just stop now, we'll just stop. If you are doing it, do it. If you're not doing it, let us. That's me. I'm either all or nothing. If I'm not doing it. If I'm doing it well. I believe that whatever is worth doing is worth doing. Just do it well. You want tiredness, just do it well. Do it well. If you're not doing it, don't do it. The many students have changed. You just go. I just go. This is why I say leave it. He was saying, I say leave it, please. But you check me on my child, I say, Jamb, I say leave it. Are you ready? Leave it. Go. People feel like I'm chasing students, but I know what I'm doing. It tells me to chase away unserious people. I know what I'm doing. I know what I'm I go say, you look at someone, why are you chasing students away? I know what I'm doing. Even today I was teaching year one. I said, go out, please go out. I know what I'm doing. He asked me to know my kind of students. That's serious. You know what you want. That's what I'm doing. So, 2 years. Let's start with the 2 year. Biology textbook, yes, your biology textbook. The topic in biology. You know, you buy normal biology textbook. Now you should have biology in your secondary school now. Just read normal biology textbook. It has circulatory system. It has cell biology. It has circulatory. It has cell biology. Are we together? Yes. So you go and but that's for biology. That one we are meeting on Thursday for that one. We'll break down. So when you are done, that we'll now come break it down and head together, discuss it together. And we'll also do 2 years. That biology, they were doing 2 years of biology past question. There's no day from after apart from tomorrow now, there's no day will come. They were not doing past question. Because sitting down on one topic and doing 1 year of past question, 1 year of past question will give you more than one topic. Because you can finish the whole organic chemistry, only 3 questions come out. Sure, you know. Because it's only 40 questions now. You can finish the whole organic chemistry, only 3 or 4 questions come. But if you finish 1 year, what you will gain from finishing one, the topics you would have touched, is more than one topic. You understand? Okay, when you continue students organic like this, do you know how many topics are anything as organic? They still cracking here, reforming. You know that it's cracking. What they call it, octane rating of it's under organic. It's wide, it's broad. Homologous series, functional, different things, reactions, structures, different. Okay, I thought isomerism, I thought isomerism is broad. Reaction, different things. Test for this. Carbohydrates, you know, this even leads to carbohydrates actually. In your secondary school organic, you learn carbohydrates, fat and oils, proteins, Bure's test for proteins. Some people don't know what I'm talking about because some secondary schools don't even finish it till the end. So most secondary schools do not finish organic chemistry till the last thing in organic chemistry, you do carbohydrates. Polymerization, monomers, polymers is a big topic. And you can branch anywhere to set questions. So when you read into, please do not be too condensed in only one topic because there are too many things that can come out. So the past question enables us to branch several topics at the same time. So the 2 years you're doing for chemistry. So we have taught now, we have taught organic. I'll give you 2 years for chemistry. Please, next time bring your past question. Bring your past, get your past question. You get a past question. If you have before, and you bring, he has one before, bring it, you must not buy this one. If you have your own, bring, it's up to date, bring, let me not stress you with money, just bring it. I don't need past question, just bring past question. Let's just be aligned with what we are doing, Sha. So the year we're going to be doing chemistry, let us start from the latest years. I want to give you an assignment that you go and do 2 years. Sit down with it and you show me your score. Don't just tell me you did it. You will show me where you did it, how you marked yourself. Because you do it, time yourself, class. Time yourself, and mark. I want to see the level you are currently and know how to push you further. You go and do 2019. Everybody write down. Please, you are going to submit this. That's why I made it a private class. The general, I'm going to follow everybody up. If you know you don't want to score high, please just leave. I'm begging you, please. I don't know where you're been to a class where someone is begging you, that is telling you, please go safe. I'm not doing this Jamb class for money. I want you to pass. If it's for money, I know how to gather students everywhere before. I'll just make it cheaper. I want a private class. I want impact. I want you to score high. So I want to see, so I can follow up everybody. I'll be seeing your records. Like I have their records in biology last week, and I told them to go and read this. I want to see how they perform when they are read that. Now, you are going to number 1 to 40. You know, name the year. Time yourself. 30 minutes. Don't give yourself more than 30 minutes. Don't give yourself more than what? 30 minutes. Don't give yourself more than 30 minutes. And mark yourself. Don't cheat. And bring it in the next class. When you come in the next class, start solving number 1. We'll do it together. Number 2. As I'm teaching number 1, any topic that number 1 falls under, anything I need to tell you about that topic, I'll teach you. In that way, if you do this in the next 3, 4 weeks, you will surprise the number of topics we have covered compared to just organic. You'll be surprised. If I told you I know what I'm doing, you see it. You'll be surprised the number of topics we have covered. If you finish 2 years of past question, Number one is one topic you have touched. Number two, number three, we'll do it. See, we finish it. By the time you are done, the next year will take another 2 years. You will go and do it. So you have tested yourself, then I'm coming to teach you again. Marry those two together and you see how your jam will look like. So you are doing 2019 and 2020. 2019 and what? 20 what? 2020. It's just 40 questions. You don't have any excuse not to do it. It's just what? 40 questions. When we come, I'll be solving them one after the other. One after the other. Yeah. That's why when you have finished, when you have done it, the correction is for me to teach you the ones you have not covered. So we have doing correction on the board. Yes. So when something you have missed, when someone teaching you, you pay more attention, right? Something that you've tried to solve in exam and you failed it. When someone is trying to show you how to do it, you need to pay more attention to it. Pay more, because now you now know that you have missed it. But when someone just teach you without testing you, you underrate it. I see that one I ask you the question now. Which of these benzene is used for this and so? Nobody knew it. When I said it, your ear open more. I didn't know. Your ear opens more something that you feel you don't know already. Your ear opens more when you feel this. This side, this very clear. This fast side, it's still fine now. If you do this usual, nothing to do with it. You just do it well. Do it what? Yeah, just next month. After that, continue your work that you're doing. Just put in the effort and do it well. I know it's not easy. That's what I'm also trying to share. One of the organic chemistry organizers for short things. I've done a lot of things today. Tomorrow it's 3 p.m. 3 to 5. Sometimes when you must have a place like this, just do it well. So class, we've come to the end of today's class. Please